So let's just talk about asymptotic notations in data structure. So the asymptotic notations are mathematical tools and they are used to represent the time complexity of algorithms in algorithm analysis. So it will help us evaluate the efficiency of an algorithm by analyzing how the algorithm's performance changes with varying the input size. So here the focus is on understanding how the runtime or the space requirement grows as we increase the input size. So now the question is why we need this asymptotic notation. So directly running and testing an algorithm might not always provide the most accurate measure of the efficiency. So the asymptotic analysis gives a general idea of the performance by focusing on the growth trend rather than exact execution time. So for larger input size, the behavior of algorithm becomes more apparent. So there are three asymptotic notations that we use. So first of all, we have the big O notation. Then secondly, we have the omega notation. And thirdly, we have the theta notation. So the big O notation describes the maximum time an algorithm can take. So it ensures that the algorithm won't perform worse than the specified upper limit. So the big O notation is basically specifies upper limit. So it is useful for worst case analysis, providing assurance that an algorithm will not exceed certain time limits for larger inputs, where the omega notation indicates the best case scenario where the algorithm will perform optimally. So the omega will define the minimum time required by an algorithm. So it is useful for understanding the fastest possible execution time. And we have the theta notation. So the theta notation lies between the big O and omega notation. So here it represents the exact growth trend of the algorithm. So it indicates the tightest possible estimate for the algorithm's time complexity. So like an example, suppose you are building one house. Now if the builder can estimate the exact cost of the construction, it will be reflected by this theta notation. So the theta notation will give us the exact cost of this house. Now if the builder guarantees that the construction will not cost more than a certain amount, this will be reflected by this big O notation. So the big O notation will give us the upper limit or upper cost of the house construction. Now if the builder guarantees that the project cost at least a certain amount, so this will be reflected by this omega notation. So the omega will give us the lower limit of the cost. So in practical, this exact costing is rare, hence the builder often provide the upper limit or the lower limit of the estimation. So similar to that, so here also we mainly use this big O notation which gives us the upper limit. So let's now talk about this big O notation. So the big O notation is a very powerful tool and it is mainly used to describe the time complexity or the space complexity of algorithm. So suppose we have two functions fn and we have gn. Now here in this graph, so this way we have this input size and this way we have the time complexity. So here we have this gn and here we have this fn. Now we can say that fn will be O of gn if there is a constant c which is greater than 0 and n naught which is greater than equal 0, such that the fn is always less than or equal to the constant c times gn for all n which is greater than equal n naught. So we can plot this cgn. So here we can have this cgn. So in simple words, we can say that Fn will be OGN if this Fn grows no faster than this CGN. So if that lies below this CGN, then Fn will be O of Gn, and here will be our N naught. N has to be greater than equal this N naught, and here we have this constant C and N naught. So that is our definition of this big O notation. Now the question is, why big O notation is so important? Because it helps to analyze the efficiency of one algorithm, and also we can use this notation to describe the runtime or the space requirements of an algorithm, which grows as the input size increases. And also because of this big O notation, the programmers can choose and compare between different algorithms and choose the most efficient one for a specific problem. And also we can use this notation to optimize the code, and also we can improve the performance of our code. So here let's now plot different time complexities. So this is our input size and this is our time complexity. So we can plot the constant O1 time complexity. So this will be one straight line, and also we can have the quadratic O(n) square time complexity. So the quadratic equation will go something like this. So here the growth is proportional to the square of the input size. And also we can plot O(n). So this is the linear growth, so it will have one straight line. Here increases linearly with this input size. And also we can have the logarithmic growth O log n. So here it represents algorithm with slower growth rates, making them highly efficient for large inputs. So this way we can use the asymptotic notation. So here the big O notation is the most useful and practical notation for algorithmic analysis, where the theta provides the most accurate measure, but it is often difficult to obtain, where the omega is useful but less relevant for most scenarios. So hope you understand about this asymptotic notation. See you in the next one. Take care.